Okay, in today's class, we'll start about the frequency allocation and the satellite subsystem and the ground station is a very big topic that we will see from Tuesday onwards. So we'll just have a quick view of the satellite frequency allocation and we'll have a small quiz in Kahoot. Okay. And also, if you're planning to conduct the quiz in as a team, also you can do it. Let's try today, or you can do it in the next class, in the coming classes. That will decide later. Okay. So we'll start. Okay. Okay, we'll get started. So the satellite frequency allocation. So we have discussed that there is a transponder which will be, what is that, accepting the signals from the transmitting earth station, then it will be amplifying and then again retransmitting it to the earth station or the location where it is required. Okay, so there will be the signal which is being transmitted from the earth station to the satellite is called to be the uplink frequency or the uplink signal, and it will be transmitted with the uplink frequency, and the signal which is transmitted from the satellite to the earth station or the place or the destination where it has to be reached, that is called to be the downlink signal. Okay, so it will be transmitted in the downlink frequency. So also we have discussed an important point that this uplink frequency and downlink frequencies should be different. Is it clear? So normally this downlink frequency will be lesser than the uplink frequency. Okay, so now let us see one by one in detail. And most of the communication satellites operate in the microwave frequency range. There is a what is the microwave frequency range? Do you know or not? You might have learned in your microwave. There is, what is that, antenna communication. Is it clear? So, for example, for military satellites, most of the satellites will be operating in microwave frequency range, except few satellites which are specifically used for military applications and other defense applications, which will be operated in the very high frequency or ultra high frequency range. And also some of the amateur radio signals, that is the Oscar satellites, which are designed for capturing the amateur radios frequency signals, they will be operating in very high frequency and ultra high frequency range. And this ultra high frequency, very high frequency and microwave signals can penetrate the ionosphere in the atmosphere with little and no attenuation and are not refracted back to the earth, as the lower frequency signals which are in the range of 3 to 30 megahertz range will be actually refracted to the earth. So well, you all know all these terminologies, ionosphere. So the different layers of the atmosphere, do you know or not? The troposphere, stratosphere, and the last uppermost part is the ionosphere, where the gases will be in the ionized state. Is it clear? So whenever the signals are being transmitted here through this atmosphere, whenever it reaches the ionosphere, it happens, as the gases are in the ionized state, it happens to get refracted, or sometimes it might be reflected back to the earth. So, but as these signals which are being transmitted to the satellite are in the range of very high frequency, ultra high frequency and the microwave range, what happens, it will not be much reflected back to the earth, and it can easily penetrate with less attenuation, or probably you can tell no attenuation at all. So all the signals will be reaching the satellite without any disturbances. That is why this range of frequency of signals are being used. So normally it will be in the range of gigahertz range. Okay. So this microwave spectrum is divided up into the frequency bands that have been allocated to the different satellites, as well as the same frequency will be allocated to the communication servicing devices such as radars, so which are being used here. So this frequency bands are normally they are designated with representation. Some kind of alphabet will be given, allocated for that. So normally they call with that name. Some alphabets will be allocated for a particular frequency range of signals. So one of the most widely used satellite communication bands is C-band. Normally they call it as C-band. So now let us move ahead and see in detail what is the frequency range of C-band, KU band, KA band. Normally they call it as Ka band and Ku band. Okay, let us see one by one in detail. So this is the frequency bands used in satellite communication. These are the frequency bands used in satellite communication. So this is the designated alphabet for the frequency band, and this is the range of frequencies. Just you can have a look at this. Okay, so the most frequently used frequency band is this C band and KU band and KA band. So depending upon our application and based on the frequency ranges, we will be using that. So normally these, what is that, megahertz frequency range will be used for satellites which are below the ionosphere, which is very closer to the atmosphere at lower height when they are placed in the LEO orbits. Okay. So when we go for the satellites which are beyond the atmosphere, what happens? They will be making use of KU and KA bands. Okay. So you can just have a look at the frequency bands. And so the uplink frequencies are normally in the range of 5.925 to 6.4 gigahertz. So in any general discussion, this is C band, the uplink is generally to be 6 gigahertz. And normally the downlink will be lesser than that. It is going to be in the range from 3.7 to 4.2 gigahertz. So these are the uplink frequencies and the downlink frequencies. But again, in any general discussion of the C band, the downlink is normally it is going to be 4 gigahertz. That is why it was represented in the previous diagram which I showed you first in the yesterday's class. What is that? Uplink it was in 6 gigahertz frequency range and downlink it was in 4 gigahertz range. And here you see the most of the new communication satellites which are launched in the recent days, they will be in KU band. It is called to be Q band. So the upward shift in the frequency is happening because of the C band as it is overcrowded here. Okay, and most of the communication satellites that are in the orbit now, and they will be, they are operating in C band only. So other bands which are we are making use of for transmitting satellites are X band and L bands. So this L band is used for the navigation purposes as well as the marine application purposes, as well as aeronautical communication and radar signals. That is used for all your what is that, aircraft applications, as they showed you in the picture. You see. So this aircraft also they will be getting communication. We can keep on monitoring. Okay, so this aeronautical services as well as other navigational purposes to locate the ships and other applications where we are using radar signals, they will be operating in this L band. So what is the range of L band here? You see, 1530 to 2700 megahertz. That is the frequency range. Okay. And coming to the other, so this is the frequency spectrum of the satellite. There is the frequency band for, it is C band communication signals. So this is the transmit and the receive bandwidths in a C band communication satellite. So normally whenever it is being transmitted here, and here will be initially for every channel, each channel will be having 36 megahertz, and there will be a separation between the next set of frequencies that is going to be God band. Okay, so this is the frequency spectrum allocation for the C band communication satellite. So this is how the signals will be transmitted in the form of zeros and ones. Okay, so everything will be digitized. And coming to the next important point here is the frequency reuse. So the same single satellite with the help of the same or the different antenna, we can make use of the same frequencies. Different antenna for different applications, and also there will be spatial isolation also. So the numerous techniques have been developed to effectively increase the bandwidth as well as the signal carrying capacity of the satellite. So these techniques are known as frequency reuse and the spatial isolation process. So how is it happening? There is one of the system for effectively doubling the bandwidth and for increasing the information carrying capacity of a satellite is known as the frequency reuse. So in this system, a communication satellite is provided with two identical set of 12 transponders will be there. Only 12 transponders will be there, but we will be able to accommodate 24 channels. Is it clear? So two identical sets where we will be using the same frequencies, but different antennas will be there. Okay, so two identical set of 12 transponders which will be having 24 channels. So that we can accommodate 24 channels with 12 transponders itself. These transponders will be having two different antennas for the same frequencies. Okay. So also another method here is polarization method. So yesterday itself we have discussed that vertically polarized signals as well as horizontally polarized signals. So one technique for keeping the transmission separate for its use from the other frequencies, when we are using the same frequencies, it should be polarized in a different ways with the different antennas. Okay, that is called to be antenna polarizations. So, for example, I think you might be learning in your antenna, is it not? Polarization of signals. So, normally, the same frequency of signals will be using two different antennas, and one antenna it will be vertically polarized, the other antenna will be horizontally polarized, so that they will not what is that interference will not be there between the same frequency of signals. Is it clear? So that we can accommodate more number of channels. So we'll be having vertically polarized signals as well as horizontally polarized signals with the help of two different antennas operating in the same frequency. So how is it happening? So the left hand circularly polarized antenna will not respond to the right hand circularly polarized antenna. So two antennas will be here. Okay, so that will be circularly polarized. In that, one will be vertically polarized and the other one will be horizontally polarized. So another technique for the effective utilization of the antenna, there is a satellite to accommodate the more number of channels as well as to increase the bandwidth is with the help of the spatial isolation process. So by using a narrow beam or the spot beam antennas, the area on the earth covered by the satellite can be divided into smaller segments. Okay, so with the help of the spot beam antennas, for this particular specific area, this kind of antennas will be used. For the other one, the different antenna can be used. And so the earth station in each segment may actually use the same frequency, but because of very narrow beam width of antennas, there is no interference between the adjacent segments. And also we know about this multiple access methods, is it not? So accommodate many to one. So when you wanted to accommodate many channels and many signals in a single channel, we'll be going for multiple access techniques. So that is the first one. It is going to be in spatial division multiple access. In that, the access to the satellite depends upon the location and not on the frequency of signals. So here you see, so to maximize the use of the available spectrum in satellite, the transponders to ensure the access of many users, as many users as possible, all the satellites use the form of multiplexing methods. So first one is the time division multiplexing. More commonly, it is called as frequency division multiple access methods. So which are widely used in all your satellites. Also, in the recent days, we are using the time division multiplexing, so that the multiple access method here is time division multiple access. So we all know that time division multiple access means a particular time duration will be given for that slot. Oh, so within that we have to transmit our signals. So this digital technique assign each user a time slot on a full bandwidth of the transponder channel. So accordingly, it will be transmitting and receiving the signals. Okay, so these are the different multiple access methods. And also, well, we all know that all the signals are being digitized. Therefore, we'll be going for the different modulation techniques, the digital modulation techniques. That is BPSK, QPSK. Although this QAM levels will be 1632 and 256. It is also used to increase the digital transmission speeds. So the data rate will be high. Okay, so this spectrum is also used for some of the newer satellites. And the other multiple access method is the code division multiple access method. So it spreads the signal allocated in that particular frequency range and it communicates. And this CDMA also provides a lot of security. So it is important in today's wireless. So most of the wireless communication systems, they are making use of this CDMA technology only. And today more and more satellites also uses SGMA, that is the spatial division multiple access methods, to give multiple access while conserving the spectrum. So within the allocated bandwidth, we will be able to accommodate more number of signals. So that is the intention of the multiple access methods. Do you understand? So the intention of multiple access method is to accommodate more number of signals within the given channel bandwidth. Okay, so that is about the different multiple access methods. So this is about the satellite subsystems. So the heart of the satellite communication system is the communication subsystem. One second. Okay, so in satellite subsystem, well, we all know that the heart of the communication satellite is the communication subsystem. So this is a set of transponders that receive the uplink signals and retransmit them to the earth in the downlink signal as a downlink signal. So this transponder is going to be a repeater that implements a wide band communication channel that can carry many simultaneous transmissions. Okay, so this is about the satellite subsystem. So, well, we all know that the transponders are supported by a variety of other housekeeping subsystems. So, these are all the essential subsystems which will be helping the satellite to operate on its own, or it helps in providing the supporting, that is the self-sustaining nature of the satellite. So, it can operate on its own without anyone to operate it. Okay, so these include, that is the first one is the first and foremost important subsystem is the power subsystem, telemetry tracking, command subsystems, the antennae which is used for the transmission and the reception process, and the propulsion system, then the altitude supply station subsystems. So these are the different subsystems that are being part of the satellite subsystem. So this entire satellite communication, it is going to have only two systems. First one is the satellite subsystem, which is the satellite, and next one is the ground station or the earth station subsystem. So first we are going to learn in detail about the satellite subsystem, which is being the integral part of the satellite. So these are the various subsystems which are being an integral part of the satellite subsystem that helps in functioning of the satellite. So the first one is the power subsystem. So this is the general block diagram of a communication satellite. You see, so this is the general block diagram of a communication satellite. So for the first one is this communication subsystem, and the first and foremost one is the power subsystem. So where is the power obtained for the satellite? From the solar panels. And also we'll be having the batteries here. So these batteries keep on charging, and this power which is being obtained from the solar system, that will be given to a regulator in order for conditioning the voltage levels, and this from the regulator the DC voltage will be supplied to all the other subsystems as a DC signal. And this, why these batteries are required means, because not always the satellite solar panels will be focusing on the sun. Is it clear? So when it is rotating in this, or in its orbit, sometimes it happens that sometimes it this face of the sun will not be focused on the solar panel. At that time the power failure will be there. And also in some cases where this eclipse are occurring, there is a solar eclipse and lunar eclipse are occurring, what happens, the sun will be dark. Okay, it happens. So what happens, the solar panels will not be able to produce the power that is being required for the subsystem functioning. Therefore, in that cases, for the fewer minutes, in order to support the power system of the satellite, the batteries which are being charged continuously, that will be supporting and supplying the power to all the other subsystems. Is it clear? So that is about the power subsystem. And next one is the communication subsystem. So whatever the signal is being received here, okay, so that is with the help of it is going to be the part of the transponder. So this transponder will be connected to the antenna subsystem. So whatever the signals are being received here, okay, so that is being given to the receiver, and there will be a frequency translator, and that is fed to the transmitter. So this transmitter, what does it do? So this transmitter, again, it will transmit through the same antenna subsystem where it is given to the communication antenna. So this is about the communication subsystem. So apart from this, so these are this is for the power supply, and this is for the communication. Apart from this, we need to monitor the system. Is it not? Keep on monitoring whether the satellite is alive, whether the satellite is functioning or not, whether the power system and other communication systems are functioning or not. So that will be monitored by this control signals and the telemetry tracking and the control subsystem. So this telemetry tracking and the control subsystems will keep on sending the signals to the earth station, indicating that the satellite is alive, it is working, all the systems are functioning in a good condition. It keeps on sending signals. And also, if any failure has occurred, we can, from the earth station, we can control over the other subsystems by sending the control signals. Okay, so the inputs from the onboard sensors will be here. So there will this telemetry tracking and the control subsystem will have many sensors. We are going to see in detail one by one. Okay, so many sensors will be there that will keep on sensing. So whether the power is there or not, what is the temperature of the systems here, and what is the position of the systems here. Everything will be tracked with the help of the sensors here, and that will be transmitted via the telemetry antenna to the ground station, so that people at the ground station will be able to monitor the satellite functioning. Okay, so that is about the telemetry tracking and the control system. So all these are control signals are given to the attitude control system as well as the propulsion subsystem. Propulsion subsystem means it keeps the satellite in its orbital position. Okay, now normally it will be in a rotating, so initially it will be with the help of other propulsion systems, it will be taken off and it will be placed in the orbit. Once that it is placed in the orbit, that propulsion system will get detached. This we have seen already, is it not? On video also we have played, we have seen, is it not? So remaining other things, when for continuous monitoring, the continuous positioning in its orbit, we need the propulsion subsystem here as well as for the attitude control system. So this we are going to see in detail one by one. So for now, in today's class, let us see the overall view of the subsystems of a satellite. So what are they? First one is the power system, which is going to supply power to the all the systems in the satellite with the help of this power from the sun with the help of the solar panels. Okay, the important point to be noted here is it has the charging batteries. So where the intention of having the charging batteries here is that whenever the solar panels are not focused to the sun, and whenever the sun power fails because of the position of the satellite or during the eclipse times, what happens? This rechargeable the batteries will be supporting the power system, and thereby it provides and supplies power to all the other systems in the satellite. Next one is the communication subsystem, which is used for communicating, that is sending and receiving the signals with the help of the antenna subsystem as well as the communication antennas. And the next one is the telemetry tracking and control system, that is used for monitoring the satellite, the functioning of all the other subsystems in the satellites. So these are the main systems that are being part of the satellite subsystems. So we will see one by one in detail in the next class. So now we will go with the Kahoot. Okay. So so far whatever we have discussed in the till today, I have taken a few questions. So we want every one of you to participate. Your chat box is enabled. Individual. Many of telling us individual. Yes, many have suggested to do it as an individual. We'll do it as an individual today. And in the next class, we'll have it as a group. You decide your partners. Okay. In the next thing, we'll have it as a team. You decide your team. Okay. Discuss with your friends and decide your team. Yeah, this is your game pin. Now change the music. We have different music today. Music you're repeating yourself. Only 60 have joined them. Make it fast. Everyone know how to go log into the Kahoot, the game pin. Yes or no? Respond. Yes. Okay. Shall we start? Only 66 people have joined. Very nice team. Yes. Every day we'll have different music. Ma'am, change the music. Yeah. Karthik is not interested in this music. Karthik didn't like the music. Yeah, it's the DJ. Something pop song also we'll have. Next Kahoot in a group team we will do. Okay. Okay, we'll go ahead. We are wasting time. What happens if a satellite is launched vertically and released at its designed altitude? Yeah. Time is up. Okay. 25 people have answered this correctly. The direction of orbit is in the same direction of rotation of the Earth is called to be. I think this question also I have answered. I have asked. So the answer here it is centigrade. When is the speed of satellite maximum in an elliptical orbit? Okay, the answer here it is 24. Very good. So what is that? Perigee is the shortest distance in an elliptical orbit, whereas apogee is the farthest distance in the orbit. Okay. The time period taken by the satellite to complete one orbit is called to be side real period. Very good. So it is going to be the important terminology when you talk about the period of the satellite. Okay, side real period. Now let us see the scoreboard. It is Sai followed by Ahalya and Shruti. This time girls are being the coming topper here. Next one, the satellites closer to the Earth travel at lower speeds than the satellites that are far away from the Earth. Only 22. See, it is actually false. What happens when they are very closer to the Earth? The speed of the satellite will be very high. It has to be high in order to overcome the Earth's gravitational pull. Is it clear? Therefore, that is what the previous question also. In an elliptical orbit, the perigee apogee is there. Perigee is the shortest distance, which is very close to the Earth. The speed will be maximum. Okay, so have it in mind. The speed of the satellite will be very high when they are very closer to the Earth. So the correct answer here it is false. Okay, next question. The period of time elapsed between the successive passes of the satellite over a given meridian of the Earth longitude is called to be synodic period. What is the angle of inclination of a satellite following an elliptical orbit? So the answer here it is 0 degree. So to use a satellite for communication relay or repeater purposes, what type of orbit will be the best? Geosynchronous. 37 people have answered it correctly. What is the point on the surface of the Earth that is directly below the satellite called to be? I think yesterday we have discussed it. So the correct answer here it is satellite. 27 people have answered it correctly. The transmitter-receiver combination in a satellite is known as? So it is going to be transponder. So most of you have answered it correctly. Very good. When your 12th question it is, the downlink frequency is lower than the uplink frequency. True or false? Yes, it is true. Maximum of people have answered it correctly. I think every day we have to have the quiz. Whatever topics we are taking, we have to revise every day by keeping Kahoot, I suppose. Very good. 60 people have answered it correctly. Which of the following is not a satellite subsystem? Today only we discussed, I think, what happened. Only 20 people have answered it correctly, which is not a satellite. So we have seen a block diagram, no? All these are part of the satellite subsystem. Ground station is not a satellite subsystem. Okay. Last but one question. What is the primary use of communication satellites? Very good. Primarily, the communication satellites are used for the telephone services. Surveillance comes under, what is that? Security services. Research comes under R&D, whereas GPS comes under the navigational purpose. Okay. Last question. A satellite signal transmitted from a satellite transponder to the Earth station is called to be the satellite transponder to Earth station. Good. It is going to be the downlink. Uplink is the one that is from the Earth station to the satellite. So other two things does not come under this category. Okay. So that is all about today for the Kahoot quiz. Now let us go to the scoreboard. Who is the topper here? Sai. Sai is the overall topper here, followed by Sonali. What happened to Sandeep? Sandeep is the topper here. Third position goes to Sai. Second position goes to Sonali and Sandeep. Mohana. Mohana. Who is Mohana? Vaivon. Who is Vaivon?